Adversarial Search, Group C, by Manuel Alejandro Umaña Rodriguez, Dahyna Martínez Pérez, PEREZ-DEJESUS, and Christopher Hans Mayens Matías. Agenda: Purpose of experiment, hypotheses, concepts, experiment setup, information, conclusion, and create some references. Purpose of experiment: implement a functional AI agent capable of playing the game of dominoes under modified Puerto Rican rules. Study the effectiveness of Monte Carlo simulation as an adversarial search strategy. Evaluate AI performance across different players configurations, such as solo play, team-based, and full AI simulations. Key questions and hypotheses. Can an AI agent using Monte Carlo simulation consistently perform effectively in different domino game configurations? Hypothesis: if the AI agent is allowed to perform a sufficient amount of Monte Carlo simulations per turn, then it will be able to outperform human players in all the game configurations.
Concepts. Experimental concepts. The platform that was used was Python programming language of high level, emphasizing code readability with the use of indentation. The subjects that were covered were adversarial search, Monte Carlo simulation, multiplayer configurations, human win ratio, AI win ratio. The game that we decided to code was the Dominoes game with Puerto Rican rules. It was a digital implementation of the classic domino game with adjusted rules for localization. This game included team-based and free-for-all configurations, as well as used the Monte Carlo simulation to make strategic decisions in real-time gameplay. The measurements that we used for performance were the amount of wins obtained by the AI divided by the number of games multiplied by 100. Experiment setups. The following tools and resources were utilized. For the domino game, an article by the website Medium, which had a base domino game, was used to gather insight. The modified domino rules that were utilized were that all the tiles were shuffled and given to 7 players each. The first play was determined by the player with the highest double tile. Each player had to match the end of their tiles to the other tiles with the exact same numbers, but if they failed to play, they could either draw a new tile or pass their turn. The game ended when a player ran out of tiles. If the game got stuck, the player with the least amount of tiles points wins. The Monte Carlo simulation is a statistical technique for calculating likelihood of various outcomes, utilizing numerous trials with randomly generated inputs based on predetermined probabilities. The outcomes are then determined by analyzing the trial results. Methods for comparing. Performance. If the AI agent successfully won a game against any number of human players, it added to its performance with the best out of 3 games, being the base for the experimentation of the effectiveness of the agent. The efficiency. If the agent could successfully beat human players at the game. If it could, it was deemed good. Method for graph creation. Data was collected by playing the game. The information was collected by playing 3 games of dominoes with different configurations for both free-for-all and in different teams. The collected data was compared to different instances of the game win ratios of the AI agent to evaluate the overall effectiveness of the agent.
Information. The following code implementation was used for the Monte Carlo algorithm in Python. Here is some information about the games where the AI was tested in different formats, utilizing both teams and without teams, having 2-player and 4-player configurations. Then here we have different performance measures for Monte Carlo AI with different simulation amounts. Here we have the graph version of the previous table to display how the improvement went as the simulations increased. Here is a tournament simulation with 3 players versus 1 AI to study how it would perform in different human configurations.
The conclusions and lessons learned. Number 1. Monte Carlo and the number of simulations. The results obtained showed that the AI struggled in scenarios where human uncertainty was prevalent. Performance significantly improved with the number of simulations per turn. Number 2. Structure environments. The performance of the AI agent increased when certain conditions were met, just having the first turn, or playing with the lowest amount of humans as they introduce unpredictability. Number 3. Computation cost and performance. Increasing the level of simulations improved the performance of the Monte Carlo AI significantly. But it came with a big computational cost. Optimizing for different levels of complexity and performance would be the best way to obtain an efficient solution. Credits and references.